Hi folks. Now that we know what acids and bases are, and we know how to name acids, we're going to look at neutralization reactions, which are perhaps the most famous of all the acid reactions. So neutralization is a reaction, chemical reaction between an acid and a base. The products of neutralization reactions are always a salt and water. So here's the summary of the kind of reaction. Acid plus base makes salt plus water. When you're predicting what salt is going to be formed, you just balance the charges of the ions to determine the correct formula for the salt. Neutralization reactions are one specific subcategory or example of double replacement reactions. For instance, if we have hydrochloric acid reacting with sodium hydroxide in a neutralization reaction, here's my formula for hydrochloric acid and for sodium hydroxide. And you can see here that I have an ionic compound plus an ionic compound, and that's kind of the standard thing we would expect to see from our reactants if it's a double replacement reaction. And therefore, my positively charged ions are going to swap places and pair up with new negatively charged partners. So my sodium pairs up with the chlorine, and the hydrogen pairs up with the hydroxide. And if you notice that hydrogen and oxygen and hydrogen, there's two hydrogens and one oxygen, so that's where our H2O comes from. So let's look at a couple of examples of neutralization reactions. If we have magnesium hydroxide, magnesium has a charge of +2, hydroxide has a charge of -1, so the correct formula is MgOH2 plus hydroiodic acid. This is where our new naming skills come in, being able to recognize what hydroiodic means. When we see that hydro, it means we have just a two-element acid, hydrogen plus one other element. And in this case, since it begins iode, I know that the element is iodine. So hydrogen ions have a charge of +1, iodine has a charge of -1, so the correct formula is Hi. This is a double displacement reaction, and it's a neutralization reaction, so I know that one of my products is water. If I have an acid plus a base, anything that has hydroxide in it is definitely a base, then they are going to react to form water. So let's see, the H2O took care of the hydroxides and the hydrogens, so it must be the magnesiums and the iodines that pair up together. Magnesium has a charge of +2, but iodine has a charge of -1, so the correct formula for magnesium iodide is Mgi2. And now we just need to balance the equation to take into account that I have two hydroxides. I'm going to end up making two waters, but it means I need two hydrogen ions as well. And now I've got two iodines, which takes care of my two iodines. And this is correctly balanced. Phosphorus acid plus potassium hydroxide. Phosphorus. This acid does not begin with hydro, so I know that it involves one of my polyatomic ions. It's not just a two-element acid, it's a three or more element acid, or three-element acid. So phosphorus, that us ending means that it was an ite phosphite ion, not phosphate, phosphite. So I look on the back of my periodic table and I see that that's PO3 with a charge of -3. But this is an acid, so it must be with hydrogens. Hydrogen only has a charge of +1, but this phosphite ion has a charge of -3. So if you prefer to use the crisscross method, 3 becomes the subscript on the hydrogen, and we have H3PO3 is phosphorus acid. Potassium hydroxide. Hydroxide is OH with a charge of -1, and potassium is in group 1, so it has a charge of +1 on its ions. So the correct formula for potassium hydroxide is KOH. This is an acid reacting with hydroxide substance, which is a base. So acid plus base makes salt plus water. I know water is going to be one of my products. And water takes care of the hydrogens and the hydroxide, so what's left over is potassium with phosphate. I'm sorry, phosphite. Potassium with phosphite. So the correct formula there will be K3PO3 because I have a charge of +1 going with a charge of -3. And then balancing this equation, I need 3 potassium hydroxide so that I can have 3 potassiums to balance out my 3 potassiums here. And therefore, with 3 hydrogens with 3 hydroxides, that makes 3 waters. And this is now a balanced neutralization reaction. I hope this helped.